Let's see, what is the domain of f? Where is f discontinuous? And C, for each value you find in part B, determine what value should be assigned to f, if any, so that f is guaranteed to be continuous. Okay, so start thinking about this problem. On as a question. So with absolute extrema, you automatically look at critical numbers and interval numbers. You don't have to check that it is increasing and decreasing. No, we have talked about the extreme value theorem. The extreme value theorem says that a continuous function always has a max and min on a closed bounded interval, and Fermat's theorem says that these can only happen at endpoints and critical numbers. So all you have to do is check those values. That's all. Okay, so who wants to give us the domain of this function? The denominator equal to 0 to find domain. So x equals 0 and x equals 3. So the domain is 0 and 3. I think that's quite correct. Everywhere except 0 and 3. What about the square root? Do we have to worry about that the square root, you can't take the square root of a negative number? What about that? So it's correct that 0 and 3 are not in the domain of the function. Are there any other numbers not in the domain? So think about that square root. So just 0 to 3 and 3 to infinity. Why can't I have negative values of x? Nature, you're saying that negative values of x are not in the domain of this function. Why is that? So what was your reasoning for not including negative numbers in the domain? You're not sure? Okay. Could someone else say maybe something about this domain? So we already know that x equals 0 and x equals 3 are not in the domain of the function. I'm asking you, we have to check also that we're not taking the square root of a negative number. Because it's a square root, we can't have negative numbers. Okay, we can't have to take the square root of a negative number. Do you set what's inside the radical to be greater than or equal to 0? Is that what you do? I mean, we can't have the square root of a negative number, so I have to require that anything under a square root is a non-negative number. That's correct. So now can you put that all together and tell me what the domain is? So x equals 0 is excluded, x equals 3 is excluded because those are make the denominator 0, so the function's undefined there. And what about any numbers where the square root also is undefined? Okay, so Yingfei says that would occur if any x value gives x squared equals negative 1/2. So Do we have an answer yet? So what values of x make the inside of the square root negative, right? That's what I keep asking, right? We can't have the square root of a negative number. So can someone tell me what x values make the inside of the square root negative? And Emily and Yingfang have suggested two methods of finding that out, right? Solving an equation or an inequality. It is always positive because x is squared. That's right. 2x squared is a positive number and plus 1 is a positive number, right? So there are no solutions to this. So that square root, we're taking the square root of a number that is always positive, so you don't actually have to worry about that. So the domain here is negative infinity to 0, 0, 3, 3 to infinity. Right, but something like that it can't be taking you, 3, 4, 5 minutes, right? This is something that has to be kind of very automatic at this point. What is the domain of a function? And thinking about square roots and thinking about that 2x squared plus 1 is always positive, so you have nothing to worry about there, right? That has to be something that's very automatic at this point. It's just like it's like algebra, right? You can't be struggling with the algebra. Okay, so now part B. So now can you tell me where is f discontinuous? Three and zero. Okay. Okay, so now part C. So for each value in part B, that's so 0 and 3, determine what value should be assigned to f, if any, to guarantee that f will be continuous there. So how do I go about finding this? Multiply by the conjugate and simplify? Why am I doing that? Why am I doing anything with the conjugate and simplifying? Is there a reason you're doing that? To find another x value? I'm not sure what you mean by find another x value. This function we've already determined is discontinuous at 0 and 3. There are no other x values at which this function is discontinuous. So I'm not sure what you mean by find another x value. Let me think about what this question is asking. Right? The question is asking me, I want to find a value of f of 0, right? The question is asking what value should we give to f of 0 so that f is continuous at x equals 0, right? Right now, f of 0 is undefined. So I have the freedom to say that I can just declare f of 0 is, say, 7, or f of 0 is 10, right? I can redefine the function. The question is asking, is there a number that we can assign to the value of f of 0 to make f continuous? Now, how would I go about finding such a value? It'd probably help if I knew what it meant for a function to be continuous at x equals 0. Something with limits? Left and right limit? Is that what it is? You're still not telling me what it means to be continuous at 0. You're just telling me limits. But can you give me a condition that tells you that f is continuous at 0? Limits from the left and the right have to equal each other. Is that all that has to be true about for continuity? I just need left limit equals right limit. Is that it? We definitely can't use direct substitution property. This function is not defined at f of 0. And the value of f of 0? Okay, so I think now we're getting somewhere. Okay. All right, so So if I want f to be continuous at x equals 0, so for f to be continuous at x equals 0, we would need, I would need that f of 0 equals the limit as x approaches 0 of f of x, right? That is the definition of continuity. That the limit as x approaches the number equals the function value. So this equation actually tells us how to find f of 0, right? If I compute this limit on the right-hand side, then that is what f of 0 has to be to make this function continuous. So let's actually now compute that limit. So limit as x goes to 0 from the right of f of x. So that's the limit, sorry, just limit as x goes to 0. And I need to find the limit of this expression, right? Square root 2x squared plus 1 minus 1 all over x squared times x minus 3. Okay, so how do I go about actually computing this limit then? Multiply top and bottom by conjugate. Right, not just multiply, but I also need to divide by it so that I make sure I don't actually change the expression. Right? So I should multiply the top and the bottom by square root 2x squared plus 1 plus 1. Okay, so what do I get then? The denominator, I get x squared times x minus 3 times square root 2x squared plus 1, right? I get all those factors together. What happens to the numerator? What do I get up top? Just 2x squared, right? Now, because I'm doing as x approaches 0, I can assume that x is not equal to 0. Remember, what does a limit mean? It means I want the values of this expression that are that occur when x is close to 0, but not quite equal to 0. So I can actually now cancel out the x squareds. And that's actually really good for us because that factor of x squared in the denominator, that was causing division by 0 in the first place, right? That's the reason I could not use the direct substitution property. So now I should be able to, right? If I substitute 0, what do we get? I get 2 over negative 3 times 1 plus 1. So I get negative 1 over 3. So in other words, I need to declare, if I say, okay, let f of x be the original function, that's fine. But f of x is not defined at x equals 0. However, if I were to make like this a piecewise function, like say that this is if x is not equal to 0, and make this, so say that f is equal to negative 1/3 if x is equal to 0, right? In other words, I'm just declaring that f of 0 is negative 1/3. This function is now continuous, right? Because it satisfies this equation that f of 0 is equal to the limit of f as x approaches 0. So that takes care of x equals 0. But now we also have to do the same thing for x equals 3. Remember that was the other point where the function was discontinuous? Right? So again, similarly, f of 3 must be the lim as x approaches 3 of f of x. So again, we have to compute that limit, and then whatever that is, that should be the declared value of f of 3. Okay, so what do you think about this? So I need to calculate this limit, and what do we think? Do I do the same thing again? I mean, why did I multiply by the conjugate to begin with in the previous example? I mean, maybe that's a good question. If I do the same thing, I mean, maybe you should think about why did we multiply and divide by the conjugate in the first place, in the first problem? To get rid of 0, which causes undefined. Okay, that's part of it, right? That's kind of getting closer to it, right? If you substitute x equals 0 into this function, you get 0 over 0. And we've learned that 0 over 0 indicates that there's some algebra that you can use algebra to cancel out certain factors. So 0 over 0 told me there was algebra to do, and we determined that the best course of action was to use the conjugate radical to actually do that. Do we have the same situation here? Do we, in this problem, do we have certain algebra that tells us these factors cancel? No, that's right. I mean, in fact, what do we actually get here for direct substitution? Remember, again, the answer is not undefined. I've said this many times. In fact, we actually did this in the previous problem, the very first one we did today, right? When I ask you for direct substitution, we do not care that the expression is undefined. We care about what is that expression. And we do not get 0 over 0 for this. If I substitute x equals 3, I absolutely do not get 0 over 0. I mean, yes, substituting x equals 3 absolutely gives an undefined expression because it gives us a denominator of 0. But what does the numerator give? The numerator does not 0. Root 19 minus 1. Right, and that is not 0. So what does that actually tell you? So direct substitution gives you square root 19 minus 1 over 0, so infinity. So the more precise way of saying this is that the left and right limits are both infinite, right? So since direct substitution gives non-zero number over 0, the left and right limits are infinite. Okay, so how does that help us conclude, or does that help us conclude what we can do for x equals 3? Remember, the goal was I need to find a value for f of 3 so that this equation is true. I need to have that f of 3 equals the limit as x approaches 3 of f of x. And I have now determined that this limit, if I take the left limit and the right limit, I should get infinity, some sort of infinity on both sides. Maybe infinity and minus infinity. Maybe they're both plus infinity, but they're both infinite. That's all I can say, the left and right limits. So what can you say? What value should I assign to f of 3? I mean, it's either all real numbers or none. That doesn't make sense. You can't have f of 3 equal to all real numbers. That doesn't make sense. DNE? We just write infinity? Can you write that f of 3 equals infinity? Is infinity a number? Infinity is not a number, right? There's no such thing as saying f of 3 equals infinity. When we write something like lim as x approaches 3 from the left of f of x equals infinity, when we write something like that, we're not saying that this limit has a value of infinity. We're not saying that infinity is a number, right? This is a shorthand for the English sentence that as x approaches 3 from the left, in other words, if I take values of x that are close to 3 but less than 3, the values of f of x get arbitrarily large. That's what this equation means. Infinity is not a number, right? So it makes no sense to say that certain things have a value of infinity. So saying that f of 3 is equal to infinity doesn't make sense. So in fact, there is no such value for f of 3, right? So we cannot assign a value to f of 3 to make f continuous at x equals 3, right? Because if I could, then that would mean that if I said that f of 3, say, equals 10, then that means that this limit would have to be 10, right? Assuming that I was able to do this to make it continuous. But this limit is not equal to 10. This limit actually doesn't even exist, right? The limit is infinite from both sides. So in particular, the limit doesn't exist, right? So there's no such value that you can assign to f of 3 to make this function continuous. Right? The idea graphically is at x equals 0, there's a hole at negative 1/3. But then at x equals 3, right, we actually have this vertical asymptote. There's no way to assign a value of f of 3 to make this continuous. Right? There's no way to make this asymptote kind of continuous. What happens at x equals 0 is because there's an open hole, I just declare, okay, f of 0 is just whatever that y value is to fill in that hole. But there's no way to make this function continuous at x equals 3. No matter where you put that point, you're never going to make this function continuous. Right? Because the limit is infinite from both sides. Questions about that problem?